In example 16, we want to construct a revenue equation, which will be a quadratic equation given some price and demand information. We have a store that recently sold a particular item for $10.95 each. At that price, they sold an average of 70 items per day. Then they raised the price to $14.35, and sales dropped, which they should because price and demand have an inverse relationship, to 63 items per day. Assuming that relationship between price and demand is linear, then in parts A and B we want to construct two linear equations. Both are price-demand equations, but in the first case we're going to do this with price as the independent variable, meaning we're going to set up two coordinate pairs where our price point will be the x-coordinate and demand will be the y-coordinate. And then we'll use Symbolab to construct a line through those 2 points. We'll get the equation, that linear equation, in y equals mx plus b form, and we'll go ahead and round those values to 4 decimal places. But we need to make one other change as well. This equation isn't about x and y, it's about price p and demand x. If price p is our independent variable, then this equation would actually be x is equal to negative 2.0588 times p plus 92.5441. This is the same information Symbolab gave us. I've just used x in place of y and p in place of x to represent the independent and dependent variables there. In part B, we'll do the same thing, but now we're told to use demand as the independent variable. We want to use demand as the independent variable. So now our first coordinate pair would be 70, comma 10.95, and 63, comma 14.35. We would go to Symbolab, we would repeat that same process. It would output something in y equals mx plus b form, and then we'll again change those variables. Instead of y, now our dependent variable is p, the price point, and those values rounded to 4 decimal places should be negative 0.4857x plus 44.95. In part C, we want to find the equation for total revenue. R will always be equal to the number of units sold times the price per item, or price per unit. That is, how many things did you sell and how much did each thing cost, or how much did you bring in for each sale. X represents our number of units sold, P is our price point, and now what we're going to do is drop in this equation that we have for P to rewrite this as X times negative 0.4857x plus 44.95. Doing that gives us an equation, R equals an expression that's in terms of a single variable. If we distribute that x through, we'll end up with negative 0.4857x squared plus 44.95 times x. So we took that price-demand equation, where demand was the independent variable, substituted that into our equation for revenue, and multiplied by x. And now we can use Symbolab to find the production levels that will yield a total revenue of $1,036. To do that, we'll solve our revenue equation. Set equal to this desired revenue of $1,036. And we get values of approximately 43 and 49. So at production levels of either 43 or 49 units, we would hit that desired revenue goal.